Hey everybody, it's Mr. Oaks. So I'm going to do some examples for basically evaluating square roots and cube roots. So the first one I have here, we have a little bit of a visual. So I have here, relate the area of the square to the length of each side. So we have this square here that I drew. Yes. Mad art skills. So I have this square here, and the area is 16 centimeters squared. When I look at that, when I think about what the term area means, it refers to the number of unit squares we can have fit into a shape. So if I look, I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16 unit squares here, so that's how we get 16, the area of 16 centimeters squared. If we look for the side lengths, namely this side here and this side here, I'm going to count how many boxes tall and how many boxes wide this square is. So we've got 1, 2, 3, 4 squares high, so that's one side length. We'll say is 4 centimeters, and then 1, 2, 3, 4 squares wide, so that's another 4 centimeters. Now if you notice, the same number shows up twice, and that's what squaring is. It's the same number multiplying itself. So when we think about the square root, what we're really saying is what number times itself gives me this number under the square root symbol. So here we have square root of 16. Well, as we see, 4 is the square root of 16 because 4 times 4 is 16. Notice, once I find the square root, that square root symbol's gone. I don't have it anymore. It's just 4. Okay? It's important because sometimes you take the square root of a number and your answer is another perfect square. If you keep going and taking the square root, you're going to get an incorrect answer. Okay? So there is why it's called a perfect square. Here, similar question. Relate the volume of the cube to the length of each side. So volume refers to a three-dimensional figure, and so with 3 dimensions we're going to have, in this case, a cube that has length, width, and height. And because it's a cube, all those things, length, width, and height, are going to be the same value. I think I did a pretty good, I think that's a pretty good cube right there. This cube's volume is 8 centimeters cubed. And in that case, what we're looking at is how many 1 by 1 by 1 little cubes fit in this shape. So if we look, again, I look and I say, well, I got 1 cube, 2 cubes, 3 cubes, 4 cubes in the front, and I'm going to have 1, 2, 3, 4 in the back. So that's a total of 8. And that's how we get 8 centimeters cubed. So just like we did before, I'm going to look at the side lengths to try to figure this out. So I notice that this side length here is 2. So I'm going to write 2, and it's actually edge length. I notice that this length in the front is also 2. Okay? You could say this is maybe the width here, this is the length, and then my height is also 2. 1, 2. So again, I wind up with the same number each time. And a cube is a number multiplying itself, basically being a factor 3 times. So we have 2 times 2 times 2. When we look at the cube root symbol, it looks similar to the square root symbol, except we have this little 3 sitting there. We call that the index. That basically tells us what type of root we're looking for. So a square root, we don't have it because it's assumed that once you see this root symbol in general, if we don't see a number kind of nestled in this little nook right here, that it's going to be, we're finding the square root. Here with a 3, we're looking for the cube root. So really what this is saying is, what number multiplying itself and then multiplying itself again gives you 8? Well, 2. So the cube root of 8 is 2. 2 times 2 times 2 is 8. 2 times 2 is 4, times 2 is 8. That's how we do it. So let's take a look at a couple of actual word problems. Okay? Might be a little bit difficult to read this, that's why I read it. Would you classify the number 169 as a perfect square, a perfect cube, both, or neither? And then we got to explain. So the first thing I would do is I would try to determine whether it's a perfect square. Now I know my perfect square is up to 16, so going through it, I know first off this number is greater than 100, so I know that my number has to be bigger than 10. So I might go, okay, well 11 times 11, that's 121, we have to go bigger. 12 times 12, 144, still got to go bigger. 13 times 13 is 169. Oh, okay, so this is a perfect square. Okay, so we have a perfect square. Well, now we got to figure out, is it a perfect cube as well? We can actually kind of say, well, we definitely know it's not neither because we know it's at least a perfect square. So I have to start going through my cubing, which basically I'm going to go and take the number and multiply it by itself. So I'm going to start at 1, but we know that 1's not going to work. 1 times 1 times 1 gives me 1. 2 times 2 times 2, as we saw earlier, that's 8. 3 times 3 times 3, 27. So you see it's getting bigger much quicker. 4 times 4 times 4 is 64. 64 actually is both a perfect square and a perfect cube, but that's not what we're looking for right now. So we'll just keep going. 5 times 5 times 5 is 125. Oh, so we're getting closer. 6 times 6 is 216. Well, we're past 169. It didn't show up. So then 169 can only be classified as a perfect square because it is 13 times 13, and nothing else works. There's no triples there. There's no cube root of 169 that's going to give us a nice number. Okay? The last one here. The volume of a cube is 512 cubic inches. What is the length of each side of the cube? So when we look at this, again, you're going to want to kind of work your way through kind of making sure, have an idea of what the perfect cubes up to 10 are. Usually when you're looking at problems and tests, and especially like state exam things, they usually don't go farther than 5 cubed, but sometimes they do. So it's good to kind of have an idea of them. So what I'm going to do is I'm going to go and I'm going to say, well, I already did up to 6. We didn't get there yet. So let's do 7 times 7 times 7. 7 cubed. 7 times 7 times 7. 343. No, that doesn't work. How else if I have a calculator? Heck, I'll just show you. Oh, I might be right. 7 times 7 is 49. Times 7. I was right the first time. What'd you do? You can. My assistant. 7 times 7. I'm telling you right now, I was right. 343. I was right the first time. I doubted myself. I shouldn't doubt myself. However, still didn't work. So let's try 8 cubed. 8 times 8 times 8. 8 times 8 is 64. Times 8. Guess what? 512. So, what is the length of each side of the cube? Well, it's cubic inches. So when we write our answer, it's just going to be inches. So you see, really when you're starting to learn perfect squares and cubes, you're going to have to go and practice to see, well, what is the cube? What's 2 times 2 times 2? What's 3 times 3 times 3? And so on and so on, until you kind of get used to it. And you see, I've known these things for a while. Even I doubted myself on this one. Most 7 times tables are, because there's just 7. There's no easy thing with 7. I hope this was helpful, especially with my little rambling going on there. But if you have any questions, please feel free to post them or ask during class. Bye.